Hello everyone. On Wednesday class this week, we began the new chapter of the textbook with 10 metrics to statistically define load characteristics. As you may know now, each feeder may have hundreds of distribution transformer, which could sum up to be 1,000 customer. Unfortunately, the lack of observability with electronic meters has made the job very difficult for utility to make the planning ahead of time. Uh, in the past, the utility have randomly picked the location and load types within a feeder to perform the load survey to identify the pattern of energy consumption. Thanks to the technology advances in communication and computing, the smart meter of AMI has now approached close to a quarter of every consumer in America with the leveraging of American Reinvestment and Recovery Act back in 2009. This may be improved over time, and if the utilities see the values of investment, it could happen at a faster pace with more coverage of metering points to their loads. Ideally, we should have one smart meter to each household so that the state of the system is completely observable. This means we still have a long way to go in order to make the system completely observable. Perhaps this may be economic alternative that to avoid massive investment. So in these pictures, what is shown here is that we are only showing one distribution transformer may have four smart meters, and then each of the actually will be telemeter back to the customer billing center to show what are the consumption. Some of them have every 15 minutes, some of them have every 20 minutes, some of them every hour, depending on about how the utility is set up, the data resolution, how frequent they want to pull the data from the consumer smart meter. You should now realize that the limited number of metering devices restrict the application to observe the state of the system in order to operate in real time. As this is one of my favorite pictures to show how complex the distribution system would be with thousands of customers within one feeder, and if you have a distribution substation with 8 feeders operating. You probably have many customers that to deal with. So we went through some basic definitions on Wednesday about the demand interval, maximum demand, diversified demand, or no coincidental demand. So this is the D sub G, D sub I, and then we talk about the power and the energy, what are the differences they are. And then we sort of go through all the basic factors of the 10 different metrics, how to quantify the data with the mean, max value, whatever that number that will be used for a certain purpose. And same thing here, as I highlight in red color 7 and 5 diversity factors and the load diversity, they are sort of done in the different manner. And as you know, this is number 5 doesn't have the unit, but number 7 do have the unit, which is a kilowatt. Number 5 doesn't have unit because it sort of cancel out on both. And then you have a loss factors and the load factors, and we're going to talk about that more next class to relate the practicality of it. As I said before, you can measure load data, how much the consumption would be, but it's pretty difficult to measure the loss factors. So we got to find out a convenient way how to do the modeling. And then the most important part of the operation, at last I mentioned, is allocation factors, which is sort of using the rating of the distribution transformer, and then by going through the root node of the metering point, and you sort of go through the prorated numbers, metering data based on the rating of the distribution transformer under a certain subsystem. And these are the examples we talk about, and this is the example of the diversity factor and load diversity. On coming Friday class, we will continue to go through more examples for the matrix we define, and I will see you then.